Now, welcome to the Q&A for at least the first part of a really big chapter. I'm fully aware that this chapter 4, wireless telecommunication systems, is a big one, but it's the first one where we actually leave these lower layers and now really look on real systems. So, first, as I explained, I will go through the second generation systems, then third, then fourth generation systems. So these are the systems currently in use, but as you might have read also in the news, more and more countries start switching off second and third generation systems. Well, this depends basically on the usage of these systems, so depending on which kind of services you're running on these systems, etc. So this will be different from country to country. I showed you some market figures, and then particularly this maybe confusing figure, confusing in the first place, where I put the different generation into relation. So as I told you, the generation, this counting started while 3G was introduced, so let's say roughly 20 years ago. And then looking back, people said, okay, now we have the third generation, okay, second generation. That was the start of the digital networks, and before that we had some first generation things, analog networks. We follow in this lecture roughly this path starting with GSM, GPRS, Edge, then UMTS, that was our UMTS, or in Japan it was called FOMA, then going to LTE. LTE, by the way, exactly today, 10 years ago, we had the first licenses, the first frequencies for LTE in Germany, 20th of May 2010, and then the first network started something like August 2010. So, and we will end in this chapter here with LTE, and then doing an outlook, everything that's around 5G, 6Gs, what are the ideas there. So that's roughly where we go through. Why covering GSM and UMTS? Although I tell you, I even sent you a link that, okay, countries will switch this off. Well, basically, the architectures are blueprints for the upcoming systems. But also, if you know the architectures, you know what has changed when looking at today's architectures. Okay. So, first question related to this. If my phone is marketed as GSM, HSPA, LTE, okay, and you see that LTE, when you use your phone in Germany, that means the phone is not using GSM. So, first of all, most of today's phones are able to handle second, third, and fourth generation. So, the phones sold in Europe usually cover GSM, in the US maybe CDMA1. Here they cover GSM, in most of the countries on this planet, GSM plus GPRS plus the new modulation scheme Edge, plus they're able to handle UMTS and LTE. And the point is, as soon as your phone detects LTE, it will use LTE. The phone always tries to use the best available technology, so to say. So there are situations where your phone falls back from LTE to 3G. This is sometimes indicated by 3G. Sometimes you got a little H, that is high-speed packet access. That's what you see here. That's a more powerful version of the classical UMTS. So, or you see something like 2G or a 2G together with an E, that means GSM using edge modulation. So the point is, the phone tries always to use the best technologies. There are already 5G phones available, but, and the problem there is that it's not 100% clear right now what is supported for 5G, and so we will see some differences there. Then when it comes to the use of the mobile phone, it depends on your network operator if the mobile phone has to pick a different technology. Why? When I introduce LTE, but I can also explain it here, there is a technology called Voice over LTE. And this is newer, this technology. That means your voice is transmitted as data packets, IP internet data packets, using the data network of LTE. And as I will explain in the context of LTE, LTE is a packet switch network. There's no circuit switching anymore, no classical telephone network inside. The other systems, 3G, 2G, etc., these systems, they are, well, a kind of hybrid systems. They have circuit switching, that's the classical circuit switching of classical telephone networks, and packet switching. So that means in some areas and for some providers and some devices, it might be the case that either the network, the provider, or the device is not able to transmit your voice data over LTE. And that means for the phone, it automatically falls back to 3G or 2G. Because there you have the circuit switched voice calls. But this will be sooner or later completely replaced by voice over LTE. And as soon as everyone can use voice over LTE, basically you can then switch off the 2G and the 3G networks. But again, there are many applications that still use the classical 2G SMS system, machine control, etc. Then there are situations where you do not have full coverage of LTE, etc. So it's not that easy to simply say, okay, let's switch off this, and then suddenly you notice, oh, there are thousands of machines that depend on 2G. So there will be some more time needed before you can actually switch off everything. And this is why some people say, maybe we switch off first the 3G networks and leave a bit of the spectrum for 2G for these special applications, and use the remaining parts of the spectrum for LTE and whatever there will be. So that's a bit of the problem, that you cannot simply say, okay, I switch off completely all the technologies. So what you see here in boldface, the acronyms, that is the way we go here for the lecture, just to give you an impression of how all this has been developed, and that you understand the basic architectures and the changes and also the advantages we have now with LTE. LTE Advanced was the first fourth generation system. There we used this OFDM, orthogonal frequency division multiplexing technology. And now in the standardization, you will find the term new radio. New radio, that is whatever it needs for the fifth generation. There we apply beamforming, much lower latency, different frequencies, whatever. But we still use, for example, LTE. We still use LTE, but now on different frequencies. So it's not the case that from the fourth to the fifth generation, we kick out the complete LTE stuff and now we have something completely new. That's why LTE is called long-term evolution and not a revolution. And so it's long-term and it's kind of an evolutionary approach. So LTE can still be used. I would say in the next 20 years, we will see LTE in all different shapes, plus additional technologies, new MIMO technologies, new cognitive radio technologies, etc. I will come to these points when I discuss 5G in the outlook. So what are the new points like? picocells with edge computing, for example. So fancy stuff, but that's left for the Outlook. 5G, and also explain, what is 6G when we apply artificial intelligence to the network and all these things. Okay, so that was roughly the path we will take in this chapter 4, so that you understand the different generations. Okay, and all the acronyms, you don't have to know all of them. You see by those many different technologies in 3G, that was around the year 2000, many different, companies and standardization bodies thought of how can we actually build a 3G systems that were competing. I will come back to this when I cover UMTS. But not all of these technologies are successful. Okay, so now let's go to the questions. So when you looked at the figures of connections and subscribers, you saw, we have many more connections compared to subscribers. So I showed you a figure, it's always outdated, was more than 10 billion cellular connections, but only 5-point-something billion unique mobile subscribers. So why do we have so many more? Exactly. We have Internet of Things, subscribers are human, machines with access. Just think of, let's say, a car, okay. That should be a car. There you have humans, okay, cars, exactly. Then you have something like the engine with some kind of preheating, whatever system, can be controlled via an app on your mobile phone. Then you have your emergency call system integrated. Again, another SIM, another subscriber. Then you have the user, then you have whatever your onboard navigation system, you have several more devices. So only you in your car, that means already maybe 6 different subscriptions. Then, or multiple SIMs or whatever. Then smart homes, exactly. All these smart whatever things, you will see that you can actually integrate this SIM, these adapters, in whatever you want. And more devices will have these capabilities. There are even some people saying that maybe in the future we will not have a classical wireless LAN anymore, but some part of the 5G technology, so that these telecommunication networks will even replace your wireless LAN at home, because this is more flexible. Then you can take out the devices. You don't have to care of setting up a wireless LAN network, etc., etc. If this is something we want, that's completely different, because then this is not under your control, etc. So that's the point. So in the end, I think it was 20 years ago, there was an article, who is driving the internet in the future? And there the clear answer was, it's mobile communication. Because already at that time we had more mobile devices than fixed devices. So the mobile applications, the mobile traffic patterns actually determine the performance of the internet. And for mobile communication, who is driving it, what is driving it, you answered it already. It's exactly there, you wrote it somewhere, it's the Internet of Things. So smart whatever stuff. So some questions. How if 5G is superior for private entities? Wi-Fi 60 gigahertz, then providers make money. Well, the idea is, for example, on campus networks, but also on apartments, why installing inside wireless LANs with all the problems? So what are the problems? Maybe when you use a lot of video conferencing, you noticed, although my wireless LAN has whatever 100 or even more megabits per second, the connection is shaky a bit. Why? And then if you switch over to cable, it's robust. It's similar, the situation between a wireless LAN and, for example, a LTE network. For LTE networks, 4G, 5G, whatever, there is someone controlling the network, avoiding overload, avoiding interference, guaranteeing you certain delays, certain bandwidth. This is not the case with the unregulated wireless LANs. So Wi-Fi networks, all your neighbors create interference. You cannot do anything against this. But if you have these regulated systems, you can guarantee delays and bandwidth. And yes, that's an advantage because you have a certain guarantee for qualities. Yes, cable fiber is always better, but still an LTE network is better than your Wi-Fi network. But the downside is someone else is controlling the network and someone else will make money. And now the market will decide if people are interested in this, if people see this problematic. For example, there are already campus networks where universities say, why investing that much money in thousands of hotspots? They're, well, outdated 5 years after installations, and that's really expensive. So why not asking a network provider setting up many picocells, and then it's the problem of the network operator to install new technology, etc. So for good or bad, so it's that's the problem. And what's quite clear, then you need real flat rates. So that was also an answer. Yes, we need flat rates. So the problem right now is that there's no provider of an LTE or whatever network that offers you a real full flat rate. But to be honest, there's also no real full flat rate when it comes to your DSL connection. So usually most of the subscriptions, they say, okay, it's kind of flat as long as you behave well. That means less than a terabyte per month or whatever. So there are also some flat rates where you can simply calculate what does it mean, full power 24 hours. So okay. So there are indeed some problems. And yes, then there are also always security, privacy implications. So someone else is controlling your network. But also you have to see with wireless LANs, this is not a high security technology. So someone else can also eavesdrop and at least find out your traffic patterns. Okay, I will come back to this when we cover the wireless LAN technologies. So the point, and there's also a question. We currently don't even have full coverage or basic coverage on highways or along railway system. That's true. Is the Wi-Fi ad hoc solution less dependent on deployed infrastructure? Yes and no. So yes, an ad hoc network. So let's say inside a train, that's no problem at all. Inside a car, that's no problem. I don't need 4G, 5G or whatever there. So I can use a Bluetooth, a Wi-Fi, whatever connection. But the problem is how to cover, for example, along railroad track, the whole area with Wi-Fi. You need antennas every, 50 meters, every 100 meters. And then you have to penetrate the windows, which doesn't work because they have a metal layer. So we have some problems. You need outside antennas, etc., etc. That's all feasible, but it's extremely expensive. So this is why we have these BTSs, the base transceiver stations of, for example, LTE, GSM, 3G technology, and they try to cover these things. So there were some projects trying to cover. I remember one between Uppsala and Stockholm using Wi-Fi. There are also projects along the highways with Wi-Fi, but typically they're too expensive. And who's making money out of this? So someone has to pay for it. And who really wants to pay today for internet connectivity? That's one of the problems. But between cars, that's something different. That's completely different. So vehicle-to-vehicle communication, you're absolutely right. This is where you can set up an ad hoc network using some kind of Wi-Fi technology. There are standards. The problem is there are competing standards, there are different standards, and now we have 5G promising you can do it also with this. You will see the new cars or several new cars already equipped with this vehicle-to-vehicle communication. The problem there is as long as you do not have the critical mass of cars using the same technology, the technology itself is more or less useless. So that's a problem. So you need a certain percentage there using this. And if you have a technology specialized to cars, and even if you then furthermore have 2-3 different standards, you have a problem. So vehicle to vehicle, the first field tests were there in the 90s, from car to car communication, FleetNet, so different projects, big projects, tested this. Yes, it works. No problem. Well, no problem, but it's feasible. But there's even IEEE standard for this in the 802.11 domain. So yes, there are Wi-Fi standards for this. But now many say, well, why not going for 5G and then using this technology? Because then in addition, you can talk vehicle to roadside. So the vehicle can talk to the road, to traffic signs, etc. So this is really a problem of who can really create a large percentage of cars using this or that technology. That's a bit of a problem. Then additionally, we have some legal issues, etc. Yes, so it's not that easy, obviously not that easy. So otherwise we'd already have this. I mean, equipping cars with wireless technology, it's not the big deal. The problem is, what do we do there? And for car-to-car communication, the legal problem is, what happens if the system, the wireless system, causes some action and something happens? Who is reliable? Can you sue the car? No. Can you sue the car vendor? No. The car in front of you, the onboard computer, who is responsible for something? So there are some more issues to solve there, besides the wireless technology. Okay, but it works, yes. So there was also the issue of the average revenue per user. Yes, in the end, it's all about money. And right now, we see the average revenue is shrinking. And that's really a big problem. So shrinking revenues, I showed you the figures. It was $10, now $8, $7. So that's not that much. So I will come back to cars in a second. So revenue, what is the problem? Think of you install every year 2,000 to 3,000 new base stations. This is expensive. What can you do as a company? You have to make money, otherwise you cannot invest. So the companies, the network providers, exactly. They have to go together with service providers. They have to go together with content providers. So content is king. So that's the problem. So we saw the same in the fixed networks. So you cannot really charge for, transmitting a bit. That's worth nothing, more or less. But you can charge for services. This is why you see all those home entertainment bundles where you say, okay, you want to see the newest whatever movies, and then you'd simply add this to your whatever contract. Or even you see that no one charges you for downloading music if you have this contract. So more and more you will see we will have contracts for content, and as no one understands bits and how many bits do you transfer for online banking, for whatever, no one knows. We know, but usually you don't know using your phone how many bits does it cost if I click here and there. But if I download a movie, then it will cost you 99 cents or something like this. So this is why all those network operators have to go together with some content providers, or they have to offer some video on demand or things like this, because they do not earn enough money. So if this average revenue per user goes down and down and down, no one will invest in new networks. That's a problem. Okay, you're right with your answers. So there was one more question about why do cars need to talk to each other using sensors? Well, the point is, assume you have a road like this, whatever, and here's your car driving with a certain speed, and here you have already an accident. All your sensors will cover a certain area, but you will not see the accident around the curve. Using radio technology, this car could send an SOS, emergency, and this will go to all the other cars. So all the other cars basically can then extend their sensor range by using this message, oh, there's something going on, please slow down. So that's the idea why cars should talk to cars. Or other examples, you have some whatever crossing here, and your car is approaching this, and then there's an ambulance coming down the road here. You cannot see this. Maybe you cannot even hear it. But using radio technology, the ambulance will signal all other cars, please stay away from this crossing. There's an ambulance approaching. So that is the idea of having this wireless technology in addition to the normal sensors you have in the cars. Okay, then a question is, who are the actors in this generation game of mobile telecommunication system? Who's actually, did you find out, or can you imagine, who says now, this is a fourth generation, and this is a third generation, and this is whatever? Again, no clear answer, as always. So who says now, this is the next generation? Yes, that's roughly, we have a new one every 10 years. So that's a good answer, but that's not really the way how the generations have been defined. So in the end, there's the International Telecommunication Union, the ITU, closely cooperating with all the standardization bodies, institutes, etc., and companies. And after many discussions, the ITU then sets certain goals for generations. So, for example, for the fourth generation, the ITU said, well, we have to reach a data rate of 1 gigabit per second. So, if you reach 1 gigabit per second, you can call your system 4G. So usually the standardization bodies, yes, like the ITU, they do not actually force you to use a certain technology, a certain multiplexing technology, but they set certain goals. So at least whatever 1 megabit per second, or at least 1 gigabit per second, or maximum delay of 20 milliseconds, something like this. And this then defines the generations. And this is also the reason why we have many systems. If we go back on this slide, you see for 3G many solutions, and they can all call themselves 3G systems. So IMT is International Mobile Telecommunications. That was the idea of the ITU, to have one global mobile telecommunication system. It did not work out in the third generation. It worked out in the fourth generation. But in the third generation, you see, they set certain goals, and then we had competing standards like IMT multi-carrier. Multi-carrier down here, CDMA 2000 is the brand name. Like we have the IMT direct spread, which is then called UMTS. We have IMT time and code and etc. etc. So the standardization bodies like ITU only say, okay, for this generation we have certain goals, And for fourth generation, for example, one goal was 1 gigabit per second. And as long as you do not reach the goal, you're not a 4G system. This is why the original LTE is not a 4G system. It's 3.9, almost 4G. LTE Advanced is a 4G system. And for the third generation, when I come to UMTS, I will show you some of the goals. Well, several systems fulfilled this. So that's one part of the answers. Then another part of the answer is that also companies define this. So companies now say, okay, this is the technology we want to integrate and this is 5G. And then together with the standardization bodies, you come up with this new term. Also marketing tries to define this. So there are many different bodies pulling at these terms and saying, oh, now this is 4G and whatever for different reasons. But officially, it's typically the ITU, well, giving you some goals the systems have to fulfill. So that's the idea, and these are the new generations. There are sometimes, as you also answered, some technology-driven generations, like the change from IP version 4 to IP version 6. That's technology-driven. So the IETF, the standardization body for many of the internet protocols, came up many years ago, already in the mid-90s, with a new version of the internet protocol, version 6. And there was also version 5, but was skipped. So after IP version 4, version 6. So there was the technology, but as long as no one adopts the technology, well, it takes some time. So, but if you jump to new technology, you have a new generation, in this case, internet protocols. So, different answers possible. All the statistics, well, check out new numbers. So they are old in the moment I put them on the slides. That's quite obvious. Then what is also important, there was this page with the simple questions. Please do go through these questions, and after chapter 4 you should be able to answer the questions. These are the typical simple questions I also answer, for example, I also ask in exams. So because the answering these questions show how much and how good you really understand different technologies. And as you will see, no one will ask you for bit patterns or something like this, because this is something you can look up in the standard. But the basic understanding is important. How does it work? How can you locate someone? We will learn this. You will see later on. How secure is it? How does this roaming work? What are the key components? That is important. So right now, you don't have to be able to answer all these questions. At the end of the whole chapter, we can go back to the questions, and then you should be able to answer them. So why don't you get the bill from the neighbor? Well, because you will learn they are so-called mobile service switching centers, and they, in the GSM system, actually control all your calls. They count the minutes. You can count bytes in the routers in the systems, and then all this data is collected, put together, and then this creates your bill, because the system is able to separate data streams from you compared to other data streams. So now you don't have to be able to answer the questions, just keep them in mind. That was the basic idea. Okay, so do you have any more questions related to this first section of the chapter? Okay. If not, then we start with the GSM system. So GSM, as I already told you, that's one of the systems. Sooner or later we will shut them down. Yes. So why learning an outdated system? Well, because you will find I would say, remainings of the systems in all the newer systems. And you have to understand the basic concepts then to learn, oh, why did we do it for LTE another way? And also some of the key ideas will survive. So that's a technology, well, starting in the early 80s, introduced to the market in the early 90s. And the key idea there was this seamless roaming across Europe. And this seamless roaming was really key to success. And this is why 2008, that's just a snapshot, well, we had so many GSM networks. We had, more than 75% of all digital mobile phones used GSM. And we had GSM used in more than 200 countries and territories, etc. I think on this planet there are only something like 190 and something countries, so there's no precise number because it depends on how many countries are accepted by the United Nations and what is a country, etc. But that's a different thing. So, well, I'm not from political science, so it's used in many regions. Rough numbers. And GSM was GSM was successful, but also services like SMS were very successful. So, going to the questions, SMS. I already mentioned it several times. Oh, this is this old technologies. Yes, I know. You all use whatever systems, but what do we still need it for? And what do the replacements require? Oh yes, two-factor authorization. Yes, that's a good thing. SMS, notification, bank account transactions. Yes. So let's say with this first answer, SMS is a, let's say, company application independent way of sending data to your mobile phone. As soon as you use some messaging service, you have a problem. So two-factor authentication. Exactly, it's not an optimal system. Absolutely, that's quite clear. When I come to security and GSM, I will tell you, not at all. This is not an end-to-end encrypted. This is not a perfect system, but it's way better than many other things if you use this two-factor authentication, two factors. That's exactly what you use for payment. So there's a regulation, a law that forces you to use two factors for authentication. So for example, for your credit card, one factor is the credit card, another factor is the PIN. And only for small amounts you can work without PIN. Or if you use a smartwatch, one factor is then again the credit card stored in the smartwatch, and the other factor is you wearing the smartwatch, unlocking the smartwatch with a PIN code. So, and this is why you don't have to enter a PIN if you use a smartwatch, for example. So it's always two-factor authentication. Yes, remote controlling of machines without internet. And that's the right and important answer. The basic requirement for all these nice telegrams and WhatsApps and iMessage and whatever system is internet connectivity. So the devices set up a connection to a server. And not only you have then a server that can control whatever messages you send. Yes, maybe you have end-to-end encryption, whatever, but still someone can read the metadata, who is talking to whom. But you need an internet connection. And if the network has really weak coverage, but at least you receive something from a GSM network, you can be sure SMS works, because SMS uses the signaling channel. And without signaling channel, there is no GSM network. So as soon as you have a GSM network, SMS will work. So, and that's the problem. Also for installation, for some things you need SMSs, and that's quite important. So SMS is still basically an important system. Also, you answered with tracking. SMS, there are invisible SMSs you can use for tracking persons. That's something I can also answer in the context of how is the localization done, but now here for short, your mobile phone is not precisely localized, usually. With a GSM system, the system does not know exactly where you are, just a rough area, so-called location area. But as soon as your phone contacts a base station, the network operator knows where you are, plus minus, let's say 100 meters. Because then your mobile phone is attached to a certain base station, you know where the base station are. So the police can send you an SMS, an invisible one. You will not notice the SMS, and this SMS then basically triggers your mobile phone to contact the base station, to receive the content of the SMS. And at this moment, the system knows where you are. So this is kind of a silent tracking. SMSs are also used to reconfigure your mobile phone without any, let's say, involvement of the user. So if your mobile phone is somewhere and even your operating system might be sleeping, you can still receive an SMS because you have your radio modem with an own operating system memory, etc. And then you receive it and you can switch certain configurations. So you will receive certain configurations via SMS. So this is why this SMS or replacements for SMSs you will find in all the different generations are still needed. So, and all the other systems, well, they need apps, they need some server support, or yes, you can also think of a peer-to-peer, a pure peer-to-peer messaging network. It works, but then you have to set up apps. Anti-theft software, exactly, that can be also controlled via SMS. So SMS is a basic service. But in the very beginning, it was free of charge, and then the operators discovered, oh, many people use it. We can charge for it, yes, make a lot of money. And then they started charging, and that was the stupid idea. Because then the messaging services came up charging nothing, and then why should you use a SMS paying something when you have the, well, more or less free messaging services? Well, you pay them with your data, but that's a different story. So the question is, can you also receive SMSs when your device is powered off? There, first of all, the question is, what does it mean your device is powered off? That means for your smartphone, you slide over the screen, you push a button, and then you will get a black screen. What does a black screen tell you? Well, basically it tells you it's a black screen. What else? Is the mobile phone switched off? Well, let's hope that at least the operating system is switched off. But as long as you have a battery in the mobile phone is never completely switched off. There's always a part, some processors, some circuits are always powered. Otherwise, you will have problems switching on, etc., etc. So, the point is, yes, we hope that if we switch off the phone, it switches off all the major components, maybe besides an internal clock, whatever. You could take away the battery. Well, for most of the phones, that's not feasible. All the future phones will have no sockets for nothing anymore. It's wireless charging, wireless whatever. So, and you don't need a SIM card. We have eSIMs, etc. So this is difficult. But now let's assume no battery, no current. Then it's really dead. Then you cannot receive anything. So basically, it's the radio modem. So if the radio modem is still up and running, your mobile phone can still talk to the network. You don't need the operating system for this. And the network operator can then also talk to your mobile phone. But let's assume the power down of a mobile phone also switches off the radio modem, then you cannot receive anything. Nothing works. And you cannot wake up the system and nothing. So that should be the standard case. I'm also only a bit cautious because, well, all you see is the black screen. I cannot look into the phone. Yes, I can check radiation, etc. And if there's no radiation from the mobile phone, then you can assume it's dead. No, hopefully. So you cannot, in the end, you cannot turn on the device with an SMS if the device is really fully switched off. If this radio modem is still running, yes, you can do everything with an SMS. You can reprogram, you can do everything. And this is exactly what you do with machines, for example. You don't have to have the operating system running. It's enough if the modem is up and running, at least capable of receiving packets, then this radio modem can switch on the remaining part of the device. This is exactly what we do in our sensor networks. So yes, and this consumes way less power compared to the full operating system. But otherwise, if the phone is really switched off, especially no battery, then you have a problem. I'm also cautious with answering this because there are examples that, for example, the GPS component in the mobile phone is again a processor, a simple operating system, some memory, independent of your operating system of the mobile phone and the operating system of the broadband, modem, etc. So in the end, you have something like 6 operating systems, 4, 5, 6 in your mobile phone. And this system, the GPS system, is still running. There were some experiments that were still running even while, for example, booting the mobile phone, collecting and tracking the device, collecting position data. So, yeah. So, there was an answer. Yes, there's a GSM phone. There's no battery and use electromagnetic waves to get power. Well, yes, you can do this. You can do, but you need a lot of power. This is called energy harvesting. That's what we do for our sensor nodes. So, for example, shaking them. You have solar panels. You have piezos. And you can also use the radio. It's called wake-on radio. And it means that the antenna alone receives enough power to do some simple processing. There are many problems with that. Main problem is how to get enough power onto the device. Just a simple comparison. If you have this anti-theft badges on clothes, for example, on stores, you have to walk through gates. And the gates are huge antennas and they need a lot of power to create a field. And as soon as you walk through the field, you can trigger the alarm or not. So yes, it's feasible to switch on something only by waves because that's energy. That was one of the very first experiments of Heinrich Hertz. But I haven't seen a mobile phone like whatever, an iPhone or a Galaxy, whatever, completely powered over the air. That's quite a lot. But yes. So if you're interested, yes, thanks. You already sent a link. So battery, cell phone. If you only use this microwatts of power as they write, then you can do this. So what we did is also this harvesting and using so-called gold cap capacitors, loading them, and then you could send something. And in the experiment, you mentioned the sender was, well, almost 10 meters away, 15 meters away. So yes, it works, but this is not a replacement for a cellular phone network with sometimes the BTS is 10 kilometers away. So that's a difference. But yes, thanks for the link. Exactly, that works. Okay, so we talked a bit about the success. Why was it such a big success? Can someone come up with a key idea? It's not better or worse compared to other second generation systems. So why was this a success, the GSM? Okay, it made the analog to digital revolution possible. There are also other digital systems. I will come back to the other issue in a second. So first of all, success. Across Europe, adoption. So there was the political will. There was also the will and the technology provided by industry. The will to have one common system across Europe. So the government only said, we want a new system, and it should allow roaming. And since 2-3 years, roaming is free of charge. That's an extremely good thing about the European Union, that we will see what happens with the UK. Again, remember those days, you have to pay a lot. Think of Switzerland, for example. As soon as you roam into Switzerland, I've done this one time, and after 5 minutes, I had a bill of more than 150 euros. Because I forgot this completely, thought, well, this is Europe, and then, oops. Okay, within European Union, free of charge. This, you can go on vacation, well, hope soon again, and that means you don't have to pay. But the initial idea was this roaming. That was the idea. Plus, you can set the GSM system on top of ISDN. So all the countries already using fixed ISDN networks for digital telephony could simply, well, less simply, use the GSM system. And that was really part of the big success. Plus, it has a big advantage that you decouple the use of the mobile station, the device, and the subscriber identity module. I will come back to this in the next section. So that's a point. So this decoupling is a big success factor. Yeah, you're right. Public Wi-Fi in many countries, you have to register and you have to receive, so you have to pay. That's true, unless you can use eduroam somewhere. So eduroam is really available in so many countries, in shopping malls, etc., etc. So it's no problem to use eduroam. And for eduroam, you only have to be a student somewhere on some university on this planet. So, but there are also networks you can use. No, there are networks, Wi-Fi networks, you don't have to register. So they are open networks, because that was in the older days when you had this problem that the Wi-Fi operator is responsible for certain things that happen with the Wi-Fi network due to a court decision. But that was actually, I think, there was a new decision that you don't have to do this 2 years ago, something like this. So it's no problem at all to provide public Wi-Fi service without any legal issues. So so there's you can have Wi-Fi. So it depends. So you don't have to really have this kind of close community or something like this. So you can have it. So there are some cities, like I remember some cities in Germany, they installed a real public Wi-Fi, and you don't need to register. Usually you only have to agree that you do not do something stupid with the network. That's quite often, but even this is not really necessary. So you only say, well, yes, I don't do anything strange with it, and then you can use it. So you don't have to register, like in some countries, with, for example, your mobile phone number, or with a real email address where they check if you really have the email address and things like this. So yes, there are some more approaches. Freifunk is also something. Okay, so and in some countries, exactly, there is no registration at all. So it really depends. So Ukraine, you're right, public Wi-Fi. And so there are many other countries. So it depends. And we also have some legacy issues. There were some strange court decisions, then technology changes, and then some of the providers are not really up to date. And so you still have this extra page before you enter the Wi-Fi, which is not necessary. Even in Germany, you don't have to do this. And I think it's annoying. It's annoying, but still quite often these are the terms and conditions, and yes, blah, blah, blah. And the problem is these extra pages is not that you have to have an extra click, but you cannot perform this automatic reconnection. So that if you have your smartphone in your pocket, it tries to automatically reconnect, then the smartphone cannot answer this first page. You have to click on something strange, whatever. So, okay. So, yes. So, but we were at GSM, Wi-Fi, cell shapes. Yes, exactly. The cells at borders. That's fun in border regions where you accidentally enter roaming without crossing the border. So, that indeed is a problem. So along the borders, the political borders, the cells can range something like 10 to 15 kilometers into the other country. And now indeed, if you enable roaming, then your mobile phone may automatically switch into an expensive network. So this is why all mobile phones allow this disabling of roaming. But within the European Union, you have just enabled, you just roam, and suddenly you're in a non-EU country, which is expensive. So, but you're right, if you live closer to the border, you can switch back and forth between the networks, and if roaming is free, charging anything, then you can simply do this. Okay, main differences between GSM and ISDN. What is the main difference? Because GSM is put on top of ISDN. So main difference, yes, it's mobile, yes, it's a cellular network, but uses wires, right? GSM, no wires for the mobile phone. Now think of services. Different carrier frequencies. You don't have carrier frequencies for ISDN. Absolutely right. What else? Think of the services. GSM is a fancy ISDN wireless wrapper. Yes. In today's terms, we could call it GSM a wireless wrapper. Yes. But with lower quality. I don't know how many of you used or ever used a real full ISDN phone. Think of the voice quality. Now compare this with GSM. So really lower quality. When we come to call setup, how long does it take before the phone rings on the other side with GSM? I can tell you in ISDN, it's 100 milliseconds, something like this. In GSM, what's your experience? Does it ring on the other side at once after you push the green button? 5 seconds, yeah, something in the second range, 5 seconds, sometimes 10 seconds, whatever. I will explain you in one of the next sections why. So the service quality is lower. Call setup takes longer, voice quality is lower. But hey, we got used to it because it's mobile. So that's a problem. So sometimes it takes really long. And the point is, why does it take that long before it starts dialing? No, the mobile phone tries to access the medium immediately. But first of all, the medium can be quite busy. You will not get access to the medium. This takes some time. Then, as I will explain to you, we have to do several database lookups. Then we have to find the other mobile phone. Then we have to perform several security checks, and this takes time. And then your mobile phone simulates something like dialing and ringing, whatever, but this is only simulation. I mean, internally, there are many messages exchanged, and you will not notice them. You can actually place your mobile phone close to a microphone, and then you hear these cracking noises. And that's exactly when your mobile phone sends some data into the network. And so you will hear before the phone rings, there are many of these cracking noises. I will come back to this also in one of the sections and explain what these messages are. So, 2 more questions. Think of 112 or 911 or 110 or whatever the number is in whatever country. What is required in the background? So you type 112. You expect someone to answer, but what do you need in the background compared to a fixed phone network? What do we need? They need a special routing, exactly. The position to find the closest emergency service. That's exactly the point. The problem is the system has to locate you and then route your emergency call that can preempt other calls, but has to route the emergency call to the closest center, police, firefighters, whoever is, so to say, responsible for answering this emergency call. So the system has to locate you and then forward the call to the emergency centers. Sometimes in some countries, the emergency centers also detect the home country of your mobile phone and then switch the language, or maybe pick an operator capable of speaking your language. That's quite often done in tourist regions. You call 112 and someone answers in your language, or at least in English instead of whatever language. So not all countries offer this, but this is some nice service, I have to say. So that is required, and that's complicated because the location areas and the cells do not match the areas and the regions where certain first response units are responsible for. So you have different operators with different layouts of networks, of cells, of regions, and you have the firefighters, police, etc. with their layout of who is responsible where. So you need databases mapping street-wise the location to the firefighters, ambulance, whatever, responsible for this street. And this is why we need this kind of mapping already in the initial days of GSM. So that's difficult. And that, by the way, is a problem of using voice over IP. For example, if you use a teleconferencing system, whatever, Skype, what else, for emergency calls. And this is why they always say this is not a system for emergency calls. Because where are you? Well, there's an IP address. But to find out the precise position based on IP address is not that simple, and it's not helpful for the police. So this is why, indeed, we have other systems that help for the localization of mobile phones. So you could think of today's mobile phones. Hey, that's quite simple. They know precisely where they are. Why can't they simply transmit the coordinates? Yes, that's feasible. And that's exactly what is done at the emergency call, e-call systems that's mandatory in the cars. There you actually code the position over the voice channel, for example, and send this over to a center that then translates this position into something the firefighters can then use and forwards the emergency calls to the appropriate emergency center. So we have, I think, Germany, 2 of these centers that collect these emergency calls, perform this localization, and then forward the calls to the appropriate emergency center. So that's one thing you can do. And then there was also a question, can't the mobile phone transmit how strong all base station receives? So a more precise localization? Yes, I will come back to this when I explain how a GSM system can roughly localize a mobile phone. But the problem is, the command and control centers of the firefighters, they were designed, let's say 20 years ago, installed 10 years ago, and then there's still a new system because those systems, they live for, let's say, 20 to 30 years. And it's not that easy to upgrade all these control centers now with the newest technologies. I mean, why not placing an emergency call in your language with automatic translation in whatever language you want? Because these new technologies are not available in these classical command and control centers. So, yes, you could do this, but this is exactly currently underway. And there's the next generation emergency call that uses IP technology. And there you actually code the last known geo coordinates in your emergency calls. And then you know where someone is. But you see, it's not that easy. If you come up with a legacy traditional system, then you implement a new service. And then suddenly you have a problem. And it doesn't work. Okay, there was one more question about cracking noises, arriving SMS. You don't hear this with modern phones. Well, it depends. What you hear is not the arriving signals. What you always hear is if your mobile phone sends something. And then depending on the sensitivity of your microphone or whatever you use, we could use a spectrum analyzer, you will hear and see something. So taking a spectrum analyzer especially, you will see exactly when your mobile phone does something, because there is radiation going out, because you have to answer. The mobile phone, even the newest one, has to acknowledge the reception of the SMS. So indeed, the newer mobile phones use less and less output power, plus maybe they operate on a frequency where your microphone or whatever setting you use doesn't have this high sensitivity. So indeed, you don't have these loud cracking noises depending on the system anymore. Okay, final questions. Characteristics, GSM, disadvantages. So disadvantages, just quick repetition, lower data rates, more security, not end-to-end, etc. What has changed? What is the same if you compare the GSM with today's LTE systems, for example? From your own experience, what is the same? What has changed? What has changed tremendously? So, compared to the early days of GSM, your first mobile phone, what is way better today? Yeah, data rates, Wi-Fi calling, voice over LTE, all these nice high data rate things. So much, much better. Higher data rates. But what is the same? What is still a disadvantage? Still same problem as we had with GSM. Encryption, exactly. We don't have real strong end-to-end encryption. So the system is not better than any of fixed phone systems. So you have encryption over the air, but there's no strong end-to-end encryption. So this is still one of the problems. So there are second generation systems with end-to-end encryption, but not GSM. Encryption, and then all the other problems you have using phone while driving, etc., etc. So these are still the same problems. Okay. So that was all to this second section of GSM.